Welcome everybody to Computer Dove. This is the first video in a series about reinforcement learning. In this video, I'm going to give you a general idea of what reinforcement learning is and what we hope to achieve by the end of this series. Also, we will talk about the problems with this simple algorithm we're going to use and possible ways to fix those problems. Reinforcement learning has many applications in manufacturing, finance, advertising, robotics, and many other things that I don't know of. So this technique has some very, very important usages in real-life applications. So let me perhaps begin by a very important question. What is reinforcement learning? Okay, so reinforcement learning is one of the many algorithms we use in machine learning. And when we're using reinforcement learning, we have a bot, which is sometimes called an agent, which is inside of an environment. In our case, it's going to be a video game, because video games are one of the best ways you can understand how reinforcement learning works. And this bot that's inside a video game has a limited set of actions that it can take. And the way we train the bot to take the right actions at the right time in the game or the environment is using some sort of accumulative reward. Now, I know this doesn't make any sense right now, but just know that we're training a bot inside of some environment how to take the right actions at the right time using some sort of accumulative reward. So we're giving it rewards for good actions, and we're giving it penalties for bad actions. The environment that I was just talking about, which is going to be a video game, is going to be, in our case, a 10 by 10 grid where a red square spawns and a blue square spawns. The red square has to catch the blue square in a limited amount of moves. So let's say we give the red square 20 moves and we tell it catch the blue square within those 20 moves. If it fails to catch the blue square within those 20 moves, it loses the game and we repeat all over again. So this game is very, very simple, and this example is very, very easy to sort of understand the intuition behind reinforcement learning. Now, you can use it for way more complex things, but that's just a very, very good starting point to learn what reinforcement learning is all about. In the next video, I'm going to discuss the rules of this video game more specifically, but just know for now that it's about a red square trying to catch a blue square. That's all it is. So the idea is we're going to train the red square on this video game for many, many, many times until the red square understands or sort of memorizes what's going on in this game so that it can be better at playing. And we call this training. So let's say we're going to train the bot for 80,000 times. It's going to play the game 80,000 times, all while just learning about the game and recording its experience. All its knowledge and experience are stored in some sort of table that we call the Q table. Before I can tell you more about the Q table, we're going to have to first define something called a state. So, I believe the best way to understand what a state is think of playing a video game and then pausing the video game at one point. So just pause the video game and then look at the picture you have while the video game is paused. This is the state of the video game. It's just the state of the video game when you pause it at a point. This is the current state that the video game is in right now. Imagine playing a game of chess and just this time between playing your move and your opponent's move when nothing is changing on the board is the state. If you can just take a picture of the game after every move, this is going to be the state. If you just take a picture of the game when it's paused at a time, that is the state. It's the state of the video game at one point in time. And so the Q table uses this state. So now let's get into what the Q table is. As we said, the Q table is all the knowledge of the bot that it gathers while training. So let's say we train the bot for 80,000 times. All the knowledge that the bot gathers while training is stored in a big table called the Q table. The Q table is a table where all the rows, each and every row, represents a state in the video game. So if a video game has 10,000 possible states that it could be in, its Q table would have 10,000 rows, a row for each state. And let's say that this game with 10,000 possible states has 4 possible actions that you could take. You could either move up, right, down, or left. Now you're going to have a column for every single action. So you have a row for every single state, and you have a column for every single action. And so, after training, after the bot has stored all of its information into this table, all it has to do really is to just identify which state it's in right now and look for the index of that state in the Q table. Once it finds that index, it's going to look at the values at that index. There is a value for each one of the 4 actions that it can take. So in this example, it can move either up, right, down, or left. Not in our video game, not in our main video game, just in this example. In this example, it can move either up, right, down, or left. So at each row, there are 4 values representing up, right, down, and left. All it has to do is to pick the action which has the highest value. So this is the way the bot stores its knowledge, by making a huge table that has rows representing the states and columns representing the actions, and the values are just the bot's estimate at how good the actions are. The more positive the value for an action, the better it is, and the more negative the action, the worse the bot thinks it is. So it identifies which state it's in, and then it transforms this state into an index that it can go to in the Q table. So it refers to that index in the Q table, and it looks at the 4 values for the 4 actions at that state. And all it has to do is to pick the action which has the highest value. So the target is really to pick the best action at a state, because it's in many different states throughout the game. Some actions are better at certain states, and some actions are worse at certain states. So this is how it stores its knowledge. It just finds which state it's in, refers to the values at that state in the Q table, okay? And we call those values the Q values. So the Q table has Q values, and we have a Q value for each action at each state. So in this example, at the first index, it's going to pick the action right, because right has the highest Q value, which is 10. In the second example, it's going to pick left, because left has the highest Q value, which is 7.5. In the third example, it's going to pick left again, because it has the highest Q value, which is negative 1.5. And on the fourth example, it's going to pick any one of right or down, because both of them have the same Q value, which is most of the time indicative of the fact that the bot really doesn't find a big difference between the consequence of either moving right or down. It thinks that both of them have the same consequence of the game. They're not really going to make a difference. It's not gonna make a big difference if it either moves right or down. So it gives them the same values. So it can either pick right or down. It doesn't think there's a big difference. I know there's lots of questions floating around your mind right now. Like, how do we build this Q table? This Q table is the result of training the bot for many, many times and then storing this knowledge in the Q table. So how do we build this Q table in the first place? How do we train the bot in the first place? So how are we going to train the bot, and how are we going to transform its experience into a Q table that has Q values? How do we get those Q values for each action at every state? How do we just transform the experience of the bot to Q values that can be stored in a table? These are all questions we're going to answer in the next videos. We're going to dive much deeper. But this is just the introduction. You have sort of an idea of what we're trying to do, the problem we're trying to solve. We're of course going to define the problem more specifically in the next videos. We're going to define the game itself. But you kind of have an idea of what's going on, like the game, which is a red square that's trying to catch a blue square. And you know the result we're trying to aim for, a big table which has a value for each and every single action it could take at every possible state in the game. So now you have this sort of knowledge about the very basic definition of the problem and the solution we want to get. How are we going to get from this basic understanding of the problem to the solution is going to be discussed in the next video. Definition of the problem and the solution we're trying to get to. In the next videos, we're going to define this problem more specifically, and we're going to define this solution more specifically and get you from the definition to the solution. And this is a very, very changing field. So every day there's new innovations, new additions that make the algorithms better. This is just the most simple way to perform it. This is going to put you on track to just be ready to learn more about reinforcement learning. This is the most vanilla, most basic way of learning about reinforcement learning. These are just the most basic algorithms. There's many, many, many variations on this algorithm. This is just going to be the most basic one of them all. I know this is counterintuitive, but I'm about to talk about the problems with our basic algorithm. Just so you know why we would need better, more advanced algorithms. This algorithm has a very, very big problem. In our case, in this series, we're going to be training a red square to catch a blue square in a 10 by 10 grid. And this is a very, very simple problem. The problem is you are making a Q table for every possible state in the game. If you encounter a state that's outside of the Q table, the bot is just going to be completely oblivious to what it should do. So it will be very, very confused no matter how many times you train it. If you introduce a new state, it's going to be totally oblivious to what the best action would be. And so in this problem, we're going to have to train it on every single state in the game. Every possible state in the game is going to be included in the Q table. Because this game is relatively simple, all of the possible states are just 10,000. The total states are just 10,000 states. So the Q table is not very big. But in more complex environments, in more complex games, the number of states can increase exponentially. It could just get way, way, way bigger. It could easily, okay, and I want you to focus here. It could easily, the number of states could easily go beyond the number of atoms in the universe. So you'd have to make a Q table that has more rows than there are atoms in the universe. This is one of the biggest problems with our algorithm. It just doesn't know how to understand. It knows how to memorize. So it forces you to memorize every single state if you want to be good at the game or at the task. So if the task is simple, you can definitely memorize all of the states in the game, all of the possible states. But once the task becomes more complex, once there's more possible states, this algorithm is just pretty much useless. There is a little addition we can add to this algorithm that's going to fix this problem, which is going to teach it to use this memory that it has memorized to understand the problem. It doesn't have a true understanding, it doesn't have true reasoning, but it's going to be able to use this experience to do well on states that it has never ever seen before. So this basic algorithm, no matter how many states you train it on, let's say you train it on 1,000,000 states and you train it on each state 1,000,000 times, but you introduce it to one other possibility in the game. You just train it on every single possible state the game could be in, and you introduce to it a similar thing that it could use this past knowledge to solve, but it memorizes. It doesn't know truly what's happening. So this small addition we're going to add, which is going to be neural networks, is going to allow the bot to use the qtable and create a function from the qtable to deal with states even if it's seeing them for the first time. Only they have to be analogous or similar to the states it has seen before, but not the same. They don't have to be the same. So this is a kind of way we can fix this algorithm. We're of course going to have to explain neural networks after making the qtable and then combine neural networks with the qtable to finally get a bot that can actually deal with new states that it's not seen before. So, yeah, this is one of the biggest problems in our algorithm. We will first teach you how to build the qtable, then we will teach you neural networks, and then we're going to combine both to get this better bot or agent or whatever you wanna call it, really. In the next video, we're going to dive a lot deeper and know how we're going to specifically train the bot. We're going to answer many of the questions that are going in your mind right now, because these questions were going around in my mind when I was first learning about this. So, yeah, and I'm very excited to teach you guys about this because it's really, really cool. Like, the amount of things you can do with this is really, really awesome. You can get really creative. So, yeah, see you in the next video.